So now that we've seen the properties of logarithms, let's work on taking expressions and expanding them using those properties of logarithms. So if I have the natural log of 3x to the 5th m squared, and I want to be able to expand this, so I just have logs that don't have any exponents on the inside and it's completely expanded out. We want to recognize that we have a product inside here in two different spots. And because we have that product, we will use the property that says if you have a product inside, then it becomes a sum of separate logarithms on the outside. So the first step would be to rewrite this as the natural log of 3 plus the natural log of x to the 5th plus the natural log of m squared. So far so good. The next part is to address the issue of the powers that are inside the logarithms. Well, we saw a property in the previous video that says a power inside just gets to be brought outside in front as a factor for that logarithm. So natural log of 3 is going to stay exactly as it is, but then we bring the 5 out in front, so 5 times the natural log of x plus 2 times the natural log of m. And now we have it completely expanded, and we can see it in its most basic components, which is made up of natural log of 3, natural log of x, and natural log of m. And if we weren't working with just x and m, but we actually had other numbers in there, suppose we had, instead of x we had 2, and instead of m we had 7. Natural log of 3 and natural log of 2 and all these other guys, those are constants. And we've known those for a very long time, so even without a calculator, you could go look them up on a logarithmic table and just do some arithmetic to work out whatever this answer would be. Wouldn't be a lot of fun, but it's definitely something that you can do without a calculator. All right, let's take a look at the next example. So this is log base 5 of the quotient of a to the 4th over b to the 7th times the square root of c. Now, because we have a quotient, we know that there's going to be subtraction involved. So I'm going to show you two different ways to work this one, and you just have to figure out what way is going to work best for you. Now, I've been doing these for years, so I usually go from here straight to the answer, but again, I see it all the time. I'm just so used to it. First, we're going to address the issue of the division. So division inside of a log indicates subtraction of the individual logs. So log base 5 of a to the 4th minus log base 5 of the entire denominator, b to the 7th, times the square root of c. Well, in the second part, we see that we have multiplication, so we know we're going to have to break that guy up. The thing to be very careful about is the fact that there's subtraction in front of all of this. So it's helpful if I put this guy in brackets, just to make sure I understand that I've got to break up that logarithm, and then I apply the negative. So let's just go into it. We can do this in a couple steps. So I'm going to leave this as log base 5 of a to the 4th minus big bracket here, big group. So log base 5 of b to the 7th plus log base 5 of the square root of c. All right, so let's do a couple steps here, and it's all going to be about bringing those powers out in front. So we have this power that needs to come out in front, this power, and we also need to work on the square root. So just as a reminder, radicals are a different form of a power, but they are still powers. They are rational powers. So something like the square root of c gets rewritten as c to the 1/2. C is to the first power, and the index of the square root is understood to be a 2. So you take the power divided by the index. So for this first one, I bring the 4 out front. Now, I don't always do this, but just for clarity, oftentimes you'll see me do a raised dot for multiplication. That way, whenever I write log base 5 of a, it's very clear that it's 4 times that, and you don't see that 4 next to the log, and you think, oh, that's 41. And then here, I'm going to bring the 7 out in front, but there's also the negative. So it's going to be a negative 7 times log base 5 of b. Don't forget there's a negative here that has to distribute, so it's going to be another minus, and the square root of c, we can see over here how that is a power of 1/2. So we'll say minus 1/2 times log base 5 of c. And there we go, it's completely expanded. So that's one way of doing this problem. Okay. And let me show you the other way. So let's go back here. We have log base 5, big fraction, we had a to the 4th over b to the 7th times the square root of c. All right. So what we can do is we can remember our properties of exponents. A to the 4th is a to the 4th. Having b to the 7th in the denominator means that this is b to the negative 7th. We know c is to the 1/2 power, but again, since it's in the denominator, that makes it negative. Okay? Maybe you see where I'm going with this if you look at the answer that's above. So then the next property would say you have a big product inside here. You've got a times the b times the c. So we have log base 5 of a to the 4th plus log base 5 of b to the negative 7th plus log base 5 of c to the negative 1/2. And now all of these powers get to come out in front. So you'll see here that I didn't work with any subtraction by having a quotient. I just rewrote the factors inside with the negative powers since they were coming from the denominator. And now there's the 4 that's out in front of log base 5 of a minus 7 times log base 5 of b, and the minus is because the power was negative, minus 1/2 log base 5 of c. So it's the same answer that I had up above. So a lot of times there's more than one way to work these, so just keep an open mind about them.